In question 3 of our stoichiometry series, we're asked, sulfuric acid, which has the chemical formula shown there, is a component of acid rain that forms when SO2, a pollutant, reacts with oxygen and water according to the simplified reaction shown underneath. Notice that it is balanced, and you need to balance your chemical reactions before doing stoichiometry problems. The generation of the electricity used in a typical medium-sized home produces 25 kilograms of sulfur dioxide per year. Assuming that there is more than enough oxygen and water, what mass of H2SO4, sulfuric acid, in kilograms can form from this much SO2? Let's start by highlighting everything that we know. We know that 25 kilograms of SO2 is formed, so I will highlight that. And next, you want to write down this information underneath where you see SO2. So we have a mass, which I'll represent with the letter M, is equal to 25 kg. Normally, molar mass is shown in grams, so you need to change this number from kilograms to grams. And we'll do that calculation on the side. Also, they are asking us to find the mass in kilograms of this. So we're looking for the mass of this chemical. Let's first convert 25 kilograms into grams. That's not hard to do. 25 kilograms times 1,000 grams per 1 kilogram. This is the conversion ratio that allows you to go from kilograms to grams and vice versa. Notice that if I multiply kilograms to this conversion ratio, the kg unit cancels out and we're left with only grams. So 25 times 1,000 is 25,000. Use 25,000 moving forward. The next thing that I want to do is find out the molar mass, which I'll represent by capital M, the molar mass of sulfur dioxide. And for this, you'll need to find the molar mass of each individual atom within one molecule of sulfur dioxide. I found these on the periodic table and I've shown them conveniently here, although they can easily be accessed. We have sulfur dioxide has a molar mass of 32.06, that's the molar mass of sulfur, plus 2 times the molar mass of oxygen. 2 because of this subscript. There are 2 oxygen atoms here. Using my calculator, I have 32.06 plus 32. I just multiply 2 and 16 together, and I end up with 64.06 grams per mole. I'll write that up here as well. Now, using these two numbers, I can actually find out the number of moles. And I'll represent that with the color brown, and I'll use the letter N. Now, how do I go from mass and molar mass to moles? It's not hard, actually. I'll take the number 25,000, this one, 25,000 grams, and multiply it by the flipped version of this number. Notice that this number has the grams at the top and moles at the bottom. Although I'll put the moles at the top and the grams at the bottom. A lot of you, if you're learning this for the first time, you might be using a triangle. And by all means, if you want to use a triangle, you can do that. Now, if we multiply these numbers, the grams unit cancel out. This is the reason why I oriented it this way, and we're left with only moles. So I'll use my calculator. 25,000 divided by 64.06, and this gives me 390.25. 390.25 moles. Keep in mind something very important. We started with 2 significant figures, so our final answer should also have 2 significant figures. So far, all of these numbers, this one and this one, have more than 2, but keep in mind that moving forward, you should stop after the second. I'll show you more of what I mean later on. So now we found the number of moles of sulfur dioxide. We need to find the equivalent number of moles of H2SO4. And to do that, we use a simple ratio. We have 2 moles of SO2 and 2 moles of H2SO4. So I'll write that ratio down, 2 to 2. And I'll write down the number of moles right underneath this column, because this column represents SO2, and that's the moles, 390.25. And we don't know the amount of equivalent moles of H2SO4, so I'll just write down an X. We have 2 ratios, and we can cross multiply to find X, this times this and this times that. So multiplying this number by 2 and multiplying x by 2 and then subsequently dividing both sides by 2, you should end up with the exact same number, where x is equal to 390.25. That is the number of moles of H2SO4. The next thing that I want to do is find the molar mass of H2SO4, and I can do that using the numbers that I had provided underneath. We have H2SO4. I'll multiply 1.008 by 2, that's the molar mass of hydrogen, plus 32.06, the molar mass of sulfur, plus 4 times 16. Using my calculator, 1.008 times 2 plus 32.06 plus 4 times 16. And this gives me 98.076. 98.076 grams per mole. I'll write that up here. 98.076 grams per mole. Now, if I multiply these two numbers together, I'll end up with the number of grams of H2SO4. So let's go ahead and do that. It's going to give us a large number because originally it was in kilograms. So multiplying this number by 390.25, that gives me 38,274 grams of H2SO4. I'll divide this number now by 1,000 because I want to go from grams, this number, into kilograms. And this gives me 38.27. 38.27 kilograms of H2SO4 from an original amount of 25 kilograms of SO2. Now remember, I spoke to you about significant figures, and we should only have 2 significant figures. So everything after this 8 is insignificant. We'll end up with 38 kilograms of H2SO4. And there you have it. That is how to solve yet another stoichiometry problem. Be sure to watch question 4 for another example.